Experiment was performed before Einstein discovered his theory of relativity. But before going to Michelson-Morley experiment, we have to cover a bit of history because Michelson-Morley experiment deals with the concept of ether. Ether is a very ancient concept, so let us try to very quickly look at that history. So in ancient civilizations, universe was thought to be made up of 5 basic elements: earth, water, fire, wind. These are the 4 elements, and then Plato thought that there is ether, and so did Aristotle. So Aristotle proposed ether as a name of the 5th element, postulated by his teacher Plato. In the following figure that we will see picture of universe. Earth was in the center of the universe, and then there were these spheres: Moon, Mercury, Venus, Sun, this sphere. So Earth is the center, Sun is also in a sphere rotating, Mercury, Moon, Mars, Jupiter, Saturn. Then all the stars were in a fixed sphere, rotating sphere, and before that there was sphere of prime mover. That was perhaps hypothetical, sphere of the prime mover. So there were 55 concentric crystalline spheres to which the celestial objects were attached. And Aristotle's book on the heavens, which was written 350 BC. Aristotle thought about the ether. Ether located in the celestial regions and heavenly bodies moved circularly. Ether moved circularly. Circular movement of ether and the linear movement of earth, water, fire, wind. So there was a difference. From that time, 2250 years almost passed, and Michelson-Morley experiment had this. They had the precise instruments to experimentally to at least ask the question of whether we can experimentally verify the existence of ether. And this experiment was done in 1887 by Michelson and Morley. They were both very good experimental physicists, and they challenged a theory which existed for 2200 years, 2300 years. Very courageous effort to challenge a theory which existed for so many years. And this experiment was done in Case Western Reserve University in Cleveland, Ohio, and published in the same year, 1887. This is the reference, American Journal of Science, 333, page 333, 345. These are the volume numbers, this is the year. Very courageous effort to experimentally challenge a notion, theoretical notion, which existed for from the time of Aristotle. So gravitation and ether, they had a link between gravitation and the concept of ether, 16th to 19th century. And many prominent scientists, they considered an underlying theory of gravity, not just gravitational force equal to g m1 m2 by r square, that is the working formula, but the dynamics behind the gravitational attraction. That was considered by great thinkers, Descartes, Isaac Newton, Lord Kelvin, Riemann, Lasage, considered some kind of a link between gravitational force and ether medium. The most famous was this Lasage's theory of gravitation. Also there were models proposed by Descartes, Newton, Riemann, Lord Kelvin, but these models could not make any substantial impact. Next came Maxwell. So in Maxwell had 4 equations, which are Maxwell's equations, and I have written here the simplified version in free space. In free space there is no charge and no current, which we can, currents are sources of magnetic field, charges are sources of electric field, but they are linked. These electric field and magnetic fields are linked. They are coupled. They satisfy differential equations which are coupled at the first order but decoupled at the second order. But those are details. But these are the mainly 4 Maxwell's equations in free space. Now you can convert these coupled equations and decouple them in second order. Then you can take curl of B and curl of E. So you can take curl of this equation, then you will get the wave equation for these fields in free space. Now if you know what is the wave equation, the structure of the wave equation, you know, I am assuming that you know what is the structure of the wave equation. Then you can see that the velocity of these waves are related with mu0 epsilon 0. Mu0 epsilon 0 has dimension of square by L square, and the velocity of these waves, they are just called c. C is mu0 epsilon 0 to the power minus half. These are the velocity of electromagnetic waves. But if you substitute mu0 and E0 here, then you will see that this c, which is the velocity of electromagnetic waves, is the same as the velocity of light. So this is why Maxwell thought that electric and magnetic fields are electromagnetic waves, and so is light. So Maxwell actually rightly thought that light is a form of electromagnetic wave. But he also thought that if it is a wave, then it needs a medium of propagation, so medium of propagation. So he said in his book he said, in several parts of this treatise is about his book, an attempt has been made to explain electromagnetic phenomena by means of mechanical action transmitted from one body to another by means of a medium occupying the space between them. The undulatory theory of light also assumes the existence of a medium, because if there is undulation, then there must be a medium which is getting undulated. That medium was necessary in our thinking. So we have now to show that the properties of electromagnetic medium, where the electromagnetic wave is propagating, is the same as the medium of the propagation of light. So that is what he thought, that we should show that the medium in which light propagates and the medium in which electromagnetic waves propagates, these two mediums are same. That's what he thought. But we will find out at the end that that medium does not exist at all. Okay. So next let's see the properties of light around 1887. At that time, as known as 1887, properties of light. The velocity of light was determined from various experiments: Jupiter's moon, aberration of light, tooth wheel. This is a very interesting experiment by Fujio. You should read about this Fujio's experiment. And Foucault's experiment, also almost correct, in 1862. This is the velocity of light in kilometers per second. At that time it was known. Then another property of light that is very important for the discussion of today is the wave nature of light. The first detailed wave theory of light was formulated by Huygens, 1690. He was able to derive laws of reflection and refraction. Then Young's double slit experiment, 1801, which showed that light shows interference of destructive and constructive interference. So this very much it shows that very conclusively it shows that the light shows constructive and destructive interference. That means it has the wave properties. And Young also explained diffraction process, and that was supported by Kirchhoff and Fresnel. And wave theory can also explain dispersion and rectilinear propagation of light as demonstrated by Fresnel. So various works in the 19th century, around the 19th century, actually after the discovery of the double slit experiment, it was more or less established that light has wave properties. That means people thought that light wave is there, and it needs a medium for propagation. It is very natural. It is very natural to think that if light is a wave, then we need a medium in which it propagates. That old philosophical thought that there is a medium called ether, and in the 19th century people saw that light has wave properties. So these two things apparently they were supporting each other. The concept of ether was really a very much building block of scientific thought till the 19th century. Next, medium for propagation of light waves. Physics theories of late 19th century. This I have taken from Wikipedia. Physics theories of the late 19th century assume that just as surface water waves, that means water waves on the surface of water bodies, must have a supporting substance, because the water waves are propagating in a medium, and that medium is water. In water, the water waves are propagating. And similarly, just as audible sound requires a medium to transmit sound waves, sound waves are propagated as air in air or water. So that is the medium. So similarly, light must also require a medium referred to as the luminiferous ether for transmitting its undulations. Because light can apparently travel through a vacuum, it was assumed that even the vacuum must be filled without obvious friction or drag. Ether was assumed to have highly unusual combination of properties. This is from Wikipedia. And so last sentence is very important. Designing experiments to investigate these properties of ether was a high priority of 19th century physics. This is from Wikipedia. Okay, so this is a transparency that we have seen. Michelson-Morley in 1887, they designed an experiment to see the properties of ether. But to see the properties of ether, Michelson-Morley used the concept of relativity, because in their interferometer crucially depended on relativity. But at that time, Einstein's relativity was not there, so Michelson-Morley used Galilean relativity. So what is Galilean relativity? Galileo, in his book in Dialogue Concerning the Two Chief World Systems in 1632, Galileo gave this idea that example, a ship traveling at constant velocity without rocking on a smooth sea. Any observer below the deck would not be able to tell whether the ship was moving or stationary. So he observed that suppose you are playing badminton. You are playing badminton in the deck of a ship which is traveling at constant velocity without rocking. Then you can just play normally. You will not understand whether you are on the deck of a ship or you are really in a gymnasium or in a stadium. So that was Galileo's observation. So that is the foundation of Galilean relativity. So let us try to see with a figure. There are two reference frames. One is XYZ frame, another is X dash Y dash Z dash frame. Now the dashed frame is moving with a velocity v with respect to the unprimed frame XYZ, such that the origin is moving along the x-axis with a velocity v. And then there is an event happening at XYZ t in the unprimed frame. But in the primed frame, the primed frame is moving with the velocity t. So that means at the time t, the coordinates x dash y dash z dash t dash, these are related with unprimed coordinates like this: x dash equal to x minus v2, y dash equal to y, z dash equal to z, t dash equal to t. That means now it is coupled. X and t are coupled. So this is the Galilean relativity. In a sense, the Galilean transformation embody the intuitive notion of addition and subtraction of velocities as vectors. If you just take the derivative, then you will see that dx dash dt dash equal to dx dt minus v, and t dash equal to t. So that means the velocity, this velocity and this velocity. There is a velocity addition. Just one derivative from there. So it is very easy. Next, let us consider now Newton's laws are invariant under Galilean transformation. So that means in the primed frame and in unprimed frame, both the frames, Newton's law is the same. So that is why it is impossible to say whether you are playing badminton inside a deck of a moving ship or you are playing on in a stadium. So this is very easy. The first law: if an object moves in a straight line with velocity u, then the absence of force, the locus is r dash equal to r0 plus ut. So r dash is r minus vt. That means you get r0 plus ut minus vt. That means you can say r0 plus u minus vt. This is again a straight line, r dash t. It's a straight line. So first law is the same, that moves in a straight line. Second law, force involves second derivative, whereas Galilean transformation is linear in time. So that means second law is automatically, there is no problem with the second law of Newton. If you take double derivative, then these both sides are same, it disappears. Third law, total momentum of a system of particles is constant in both frames in the absence of external force. This saying the equivalent to saying that action and reaction is the same. It remains constant. It does not. So that means in both in the frames. So if you consider the unprimed frame, we will see that momentum is constant, and if you are seeing the primed frame, then you will see that momentum is a constant. These constants are not same, but they are constant. Constant in the unprimed frame, constant in the primed frame. Next we see this experimental setup. So Earth is moving around the Sun. This is the moving around the Sun, and at any instance Earth has a linear velocity. Light is propagating in ether, and in ether light has a property that it has a velocity c. So if we can set the arms of the interferometer once along the one arm along this direction of the velocity of Earth. So this is a crucial thing. So there is a direction in which Earth is moving, and we have to set one arm of the interferometer along this direction. So then we can get two different velocities, c plus v and c minus v. We will see how. It's by reflection. We will get two different velocities. Now, if we can align longitudinal axis of interferometer along the direction v, then according to Galilean velocity addition, we can achieve two different velocities of light rays. One when going towards the mirror, and another after the ray is reflected. So this is very crucial. Anyway, let us see next. This is the experimental setup. So there is a light source. This is the velocity v. Velocity v. Which velocity v? Velocity v is here. This is the velocity v. That is the velocity of Earth through ether. That means the instrument itself is moving with a velocity v through ether, because Earth is moving with a velocity v through ether. So this velocity is reflected here. This velocity v. The interferometer itself is moving with a velocity v through ether, and we have aligned one arm of the interferometer. This is one arm, this is another arm. One arm of the interferometer along the direction v, and another arm is perpendicular to the direction v. So this is source of light, and it is split into. One goes, half of it goes this side, half of it goes this side. There is a mirror, so then it gets reflected here. But by that time this splitter has moved here because of this velocity. But the distance between the splitter and the mirror always remains L. There is no length contraction or something, anything like that. So this L and this L is the same. This is pre-Einstein theory. So that means time is L by c minus v plus L by c plus v. This is time, and another time is here. So there is a right angle triangle. So hypotenuse. What is hypotenuse? Hypotenuse is root over v square. This time is tt. v square t square by 4 plus L square, because this is Vt by 2, this is Vt by 2, v square t square by 4 plus L square, this is L, this is hypotenuse, and you have to multiply hypotenuse with 2 because it is going and coming back. So 2 hypotenuse is CTT. So you can solve this equation, quadratic equation. Then Tt is 2L by C, 1 by root 1 minus v square by c square. And here TL by C minus v plus L by C plus v, that is 2L by C, 1 minus v square by c square. So this is all pre-relativity days. So along this direction time will be this, along this direction time will be this. So these two times are different. That means the two light beams, one is transmitted, another is reflected, they will be out of phase because the time of travel is different, so they must be out of phase. That means the central fringe cannot be a bright fringe, because bright fringe is obtained when they are in phase. So if it is out of phase, there will be fringe shift. So that fringe shift has to be detected by Michelson and Morley by this interferometer. And this interferometer was very sensitive because Michelson and Morley, they were very great experimentalists, and their interferometer, they have worked through many years to construct their interferometer which can detect fringe shift of that order. So Michelson-Morley experiment 1887 was a very sensitive instrument. Even these days you will find Michelson-Morley experiment in the laboratories, physics laboratories, where students are doing Michelson-Morley experiment. It is so important. So this interferometer had the capacity of seeing this fringe shift because of this difference in time. The time in the longitudinal direction and the time in the transverse direction are different. But Michelson-Morley experiment did not find any fringe shift. So they moved the arms of this interferometer in all possible angles, and they experiment after 6 months in spring. Then also they did not get any fringe shift. So that means that that is a null result. Other versions of experiment were carried out with increasing sophistication, but the Michelson-Morley experiment were the first with sufficient accuracy to challenge the existence of ether. So here, suppose the ether is also moving with the same velocity as the Earth's velocity. So then the velocity of Earth with respect to ether will be 0. So then we will not get a fringe shift. But then after 6 months, the velocity should, because if ether and Earth by some chance has the same velocity, then there is no relative velocity between ether and Earth. So then maybe you don't get fringe shift. But then after 6 months, the Earth is moving in the opposite direction. Then of course you have to see the fringe shift. If by some chance Earth's velocity around the Sun and ether's velocity, ether wind's velocity is the same, but even that did not work. So other versions of the experiment were carried out with